this is Andrea Kane, and I'm here with HIT 352, Health Information Systems. And we are now moving into Chapter 2. This is Week 3, and we are going to be focusing on information integrity and data quality. So let's go. Our learning objectives. According to our book, we are going to identify the various data sources that populate the EHR. We will list and give examples of each AHIMA data quality management model characteristics. Choose appropriate field type for a data element, make recommendations to address data quality and data integrity issues. And we also have course objectives and learning objectives. If you take a look at your syllabus, this week we are focusing on learning outcomes of 8.2, 8.3, 8.4, which involves information and computer technologies, health information specialty systems, and data storage and retrieval. And when you look at the unit objectives, that's 9.2.1 through 9.2.7, 9.3.1 through 9.3.3, and 9.41.1 through 9.4.7. And we will actually be spending our time, last week we had those same course objectives, and it looks like we will hang on to those for at least the next 6 to 8 weeks. So no need to worry whether or not they will be mastered because we will be covering them. So let's get back to our slides here. The introduction is that data must be accurate, timely, and complete. Yes, whether you're talking documentation or data, it needs to be accurate, timely, and complete. What are some primary data sources? They are the health record, or they come directly from the source. So secondary data sources are not going to be the health record, and they're not going to come from directly from the source. They're going to be derived from that primary data. And examples of secondary data sources are indices or indexes, an index, registries, and other databases. So again, when we're talking about a primary data source, that is the EHR, or it came directly from the source. The secondary data sources have pulled information from those primary data sources, and that's what you're looking at. Okay, screen design. Well, you need a clear design to assist users with data entry. Has anyone ever gone in to fill out an electronic form and is really not clear what they want you to enter or where they want you to enter it or in what format they want you to enter it? It can be confusing. So when you talk about screen design, it needs to be laid out in a logical manner, and it needs to be clearly identified. When you're talking about data capture, that is the process of recording healthcare-related data in a health record system or clinical database. So data capture is getting that data into the system or the database. If you don't capture it correctly or accurately or timely or get all aspects of the data, you end up with poor quality care and poor business decisions because so many people are relying on this information, on this data. So you can see why it is not best practice to have a caregiver take someone's vitals and write them on a piece of paper and enter them into the EHR 2 hours later. That is not best practice. What would be best practice is if the blood pressure cuff or other instruments that are being used, like a thermometer, to capture the vital signs is directly entering the information at the time that it is captured into the EHR. Now, granted, that is a bit more expensive in terms of technology, but you get the quality out of it and the ability to make better decisions. Not to mention, it lessens your risk significantly. So let's talk about data capture. It comes from direct entry, keyboard, mouse, or other device, a hotspot. It can have unstructured data fields, meaning that it can be free text. And when you have free text, you're going to have spelling errors. It's just saying from experience, when you have unstructured data fields and anyone can type anything in, the quality of that data is not going to be as good as using structured data fields. But the good part of using unstructured data fields is you may collect information that you didn't even know was available or needed until after you collect it through that free text. So you've got those opportunities there. With free text, it's a lot harder to mandate or get consistent answers that you can use to trend. But again, it's a great extra resource to have to capture maybe things that you didn't realize needed to be captured. Now, structured data fields, that's where they guide the user during the data entry process, limiting what they can enter in the field. So a structured data field would be a drop-down that gives you options, and you have to choose from one of those options. And that's what we talked about. A drop-down menu, a checkbox, radio buttons, numeric field, date field, time field, auto numbering, those types of things. Those are all structured data capture. Template-based data entry, that is a combination of both. And then you have speech recognition. You have front-end speech recognition where it is translating the voice as the person is dictating it, and they can make those changes right then and there. Back-end speech recognition basically takes the voice after it's been recorded, runs it through the technology that translates it, and then gives you a document that then has to be edited on the back end after the fact. So that's the difference between front-end speech recognition and back-end speech recognition. There are pros and cons to both. I mean, there are challenges to both. You're relying, and there's a question as to who edits. On the front end, it's whoever is creating the documentation that does the editing. On the back end, it can sometimes be someone other than the person that created the documentation doing the editing. However, the person who created the documentation has to go back end and sign off on it. They have to review it and sign off on it. Natural language processing is the technology that converts human language in either a structured or unstructured format into data that can be translated and then manipulated by computer systems. So you're going to want to make sure that you know all of these terms and understand them and what they mean. Data integrity is the extent to which healthcare data is complete, accurate, consistent, and timely. So the integrity, the honesty, the value, the reliableness, that is going to depend on, is it complete, is it accurate, consistent, timely. Data quality is then the reliability and effectiveness of data for its intended uses in operations, decision-making, and planning. So integrity is it trustworthy? And data quality is, can it be used for all of these other services? Have we proven that it's going to be able to be used? Required fields, that's part of data integrity. Sometimes you have those hard stops that insist that you have to fill it out or give an answer before you can move on. Edit checks, is it illogical? For instance, let's say that you have a medication range and what you put in, maybe you're documenting what the nurse gave the patient. If it's outside of that range, it may mark it as being, ooh, red flag here. You need to go back and double check, is this really right? Because it's outside of what we would expect as a range. And then format, is it in the right format? Is it coming through with a different, if it's supposed to be mLs that you're reporting, is it coming through as cc's or something else, or units? So data quality management, and this is a good quote, the business processes that ensure the integrity of an organization's data during collection, application, warehousing, and analysis. That's what data quality management is, those business processes. So under data quality management, we talk about data accessibility. Do people have the ability to get to it who have a right and a need to know to be able to care for the patient or do their job? Do they have that accessibility to it so that they can do what they need to do when they need to do it? Is it accurate? We need to manage that. We need to do quantitative analysis on the data and qualitative analysis on the data. And if you're not sure of quantitative versus qualitative, go back and look up the differences between the two. You can think about that because we often talked about quantitative analysis of a medical record versus qualitative, and that's really what they're talking about here. Not just in terms of record completion, but in terms of the data itself. Data comprehensiveness is another part of quality management. And typically you're going to want to have a physician advisor be reviewing other physician documentation or provider documentation. You want to have peer review type situations set up so that that can be done. Oftentimes this is done through the ongoing performance evaluation, and where you'll have with medical staff credentialing, privileging, where they go through and the department chair reviews a certain number of charts and make sure they're appropriate. That would be sort of physician advisor situation. Peer review might be that there's a case and so they have 2 or 3 or 4 other physicians of that same specialty and they review the case in question. Is this the same kind of care I would have done? Is this the same kind of documentation I would have done? And really look at it from that perspective. Then, of course, there's data consistency. Are we doing things the same way every time? Are we always calling it the same thing? Are we always capturing the data in the same way? And this is where mapping comes into play, where if you've got terms that you're mapping together in a health information system, are you making sure that your definitions match and that your mapping is clear? That there's either a one-to-one comparison or that these 3 things are going to all map to one place. It's consistent. Data currency. Is it current? Is it being captured and moved to where it needs to be? Is it available? Are your interfaces in place? Data definition. Again, how you define it. The granularity of it. How far down does it go and how clear is it at that very basic level? Data precision. So that it's not a range if it needs to be a single value. Relevancy. You can capture data on anything, but that doesn't mean it's relevant. There needs to be some relevancy there. Just because you can capture it doesn't mean you should or shouldn't. There needs to be relevancy. Someone needs to be looking from a quality management perspective at, is this being required, or is this necessary, or will we use it? Is this a regulatory, are we capturing this for a regulatory reason? Are we capturing it because we've always done it that way? Or because 20 years ago in the paper world we had to? You've got to talk about relevancy. Data timeliness. Again, I gave the example earlier of a patient caregiver who's still manually taking vital signs, writing them on a slip of paper, and then eventually adding them into the EHR, and that may not happen for a few hours. Well, let's give an example of maybe an intensive care unit, and you have a nurse, and nurses are in the intensive care unit are either supposed to be one-on-one per patient or 1 to 2 patients. They're not supposed to exceed 1 to 2 patients. Well, let's say that there's a staffing shortage because in this COVID world, ICUs are full and there are staffing shortages. And let's say you've got a 1 to 4 patient ratio on this poor ICU nurse who is just overwhelmed and trying to move between patients, give meds, give treatments, follow orders, follow up on things, and for whatever reason, something didn't get charted. And let's just say this ICU is managed remotely by intensivists at a large teaching facility, and the nurse neglects to get her charting done because she's so busy giving actual hands-on care to her patients. And a decision gets made, an order gets given without her data, because by the time she gets it into the system, the order's already been made by the intensivist, and you can see timeliness matters. It absolutely matters. And not just from a risk perspective, but really from a time frame, an understanding, a decision making, a patient caregiving, all of that. So what are some data integrity issues you might run across? Well, data cleansing. Is there a process in place of checking internal consistency and duplication, as well as identifying outliers and missing data? Is there anybody looking at the contents of the information to make sure that we're not missing something? That if we've got some really strange outliers, that we're following up on why this is happening or who's doing what? Is there a trend here we need to be aware of? Are the consistency rules that we built in place, are they effective? Are they working? Are they giving us that consistency, or are we still getting a whole bunch of a wide variety of things that really aren't helpful? Are we doing duplication? How many of us have ever gone maybe to the hospital and we have, you can say whatever kind of visit you want. How many times have you been asked your name, your date of birth, your demographic information like your address, your phone number, all those types of things? And when you want to say, well, I gave it to them up front, it's one thing about your name and your date of birth because they use that to identify you. But if you're being asked, who's your primary care physician or your primary care provider, what kind of insurance do you have, and you're getting asked that as you go from, let's say, an outpatient clinic to the lab to radiology to billing, or if you're checking out after you've done these services and they're still asking you that, sometimes you want to say you have it in your system. And I was asked that at registration, I was asked that at the clinic, I was asked that at the lab, I was asked that at radiology. It gets very frustrating when there's duplication. And what happens when the duplication is different and you come up with all these different answers? Data mapping, making sure that you are mapping things correctly, especially when you're doing a system upgrade, or even more critical is when you're changing systems. There are a lot of healthcare organizations that had Cerner as their inpatient hospital IT system, or EHR, I should say, and they decided to move to Epic. That seems to be the latest trend. And so you've got to make sure when you're mapping your data from Cerner to Epic so that it can cross over and be available to you in your new system, you've got to make sure your mapping is incredibly accurate. First of all, when you sit down to map it, you need to talk through it, walk through it. Then you need to make sure that you do a small mapping and you test it. And you don't just do one test, but you do many tests. And you don't just test a handful of patients, you test thousands of patients, and you go back through and you look to see, did the mapping work? Is it accurate? Did the data come through the way it should have? Is it reflecting accurately what it was in the old system in the new system? There are documentation integrity errors with patient identification. It is possible to have patients who have the same first and last name and date of birth. That is very possible, and if you pick the wrong one, you're putting the wrong information on the wrong patient. And how do we capture that? How do we figure that out? Authorship. How do we make sure that whoever's authoring that entry really is the person that is in there doing that they haven't shared their password, or that no one else is doing that, or came behind them, sat down while they were still logged in and did something? Dictation errors without editing is a huge one. You think about providers, healthcare providers, they are there to care for patients. That's their passion. That's what they want to do. But they have to do a lot of other things as well. And so when they're looking for ways to save time, sometimes providers use the cop-out of, oh, well, this was signed but not reviewed. And that's supposed to excuse whatever errors were there from voice recognition or from their own documentation, what they entered. From a risk perspective, that is very bad practice. I will tell you that up front from experience. That is a very bad practice. But sometimes you have to have a one-on-one conversation with a provider, sometimes multiple times, and sometimes you get people higher up in the food chain to have that discussion that if there are voice recognition errors, they need to be edited. That could really come back to bite someone if they are in a lawsuit, a provider in a lawsuit. Copying and pasting is a huge data integrity issue that continues. To some extent, you can kind of understand. If you go back to the old days and you think about transcription and you think about a doctor who does carpal tunnel releases, that's a pretty simple, straightforward procedure, carpal tunnel release. Essentially, they go through the same steps every time with every patient. It might change from left wrist to right wrist or one wrist to both wrists, but for the most part, that procedure is identical and it has all the same steps and it's very straightforward. So in the olden days, back in transcription, they had what were called normals. And that normal procedure verbiage was what the doctor, the surgeon, wanted inserted in his op report. And then he or she would give whatever or was unique to that patient, and that was added. Well, when we moved away from transcription into the voice recognition world and into the EHR world, that type of situation switched and became copying and pasting, where essentially they go in and let's say you have a hospitalist and they're in a hurry because they've got 40 patients to see today, and many of those are very ill and going to take some time talking with the patient, talking with the family, coming up with maybe some different medication changes, those types of things. They have a progress note from yesterday that they feel like is pretty detailed, and maybe the patient situation hasn't changed all that much from yesterday. So to save time, they go in, click, copy, go into today's progress note, paste. Well, the problem with that is that every day for every patient is not the same. And what you did yesterday, you may or may not be doing today. And you may carry in vital signs and other information from yesterday into today's record that does not really reflect what's happening with the current vital signs with the patient today. Copying and pasting has gotten a number of providers into trouble, and it is something that has not yet been outlawed, so to speak, by CMS, but is strongly frowned upon by a lot of agencies and is to be something done very carefully and to be avoided if at all possible. But it is definitely a data integrity issue because once it's copied and pasted, that becomes the truth rather than what really happened with that patient, because that's the documentation. Another data integrity issue you may run across has to do with amendments to the medical record. How do you make sure that the most current version is available and that all of the prior versions are kept and they are timed, dated, and you have authentication to verify who made them, when they made them, and what did they do to amend them? How did they amend them? What words did they eliminate? What numbers did they eliminate? What did they mark as being an error and why? So amendments you have to be really careful about. Data quality measures. You want to look at data from a quality perspective, definitely, but there are data quality measures. They are meant to look at the quantitative side of the quality of care. And they are supposed to be compared to a criteria or criterion. Criterion is singular, criteria is plural. And depending on the data quality measures that you use, you have to be really careful that you're being consistent and that they make sense. So just a heads up. Here are some references, a reference that they used for this. You can definitely take a look at it there at AHIMA's website. And that's all I have for Chapter 2. So you'll have a discussion this week, 2 assignments, plus we're going to make sure that you can get into AHIMA's VLab and EHR Go. We're going to test your accesses this week because next week we will start using those. And then you'll have a quiz over Chapter 2. Hope you're doing well. Talk to you again soon. Bye.